Dear students, today we will be discussing about Newton's rings apparatus. It is an arrangement and experimental setup with which we are able to obtain the interference pattern again by the scheme of division of amplitude or division of intensity, right? So the entire experimental setup goes like this. This is the source of light which emits light waves in all possible directions. It is rather an extended source, right? So the first thing is to render the light parallel. That we do with the help of a collimating lens or a convex lens, right? So the light is rendered parallel. It emerges like this, right? Next we place a glass plate at an angle of 45 degree. This is at an angle of 45 degree. So what happens? That this light strikes the glass plate, a part of it is reflected, a part of it is transmitted, again a part of it is reflected, a part is transmitted, right? Beneath we have a plano-convex lens that is mounted on a plain glass plate. So this traps a air film that has certain thickness, say T, right? Now, so once the light rays hit this, they follow this scheme, they go down, again they are reflected, up, again it goes down, it is reflected back, and we see the final light rays by way of a telescope. So we get coherent sources that produce the interference pattern, and that is visible through the telescope, right? Now the conditions of constructive and destructive interference remain the same. That is, what is the total path difference, by the way? Since T is the thickness of the film and these light rays have to travel twice, once while coming and once while going back, so the path difference is 2T. And we know in case of constructive interference we put it equal to n lambda, but because a parameter of reflection is involved, again we have repeated these things many times, that an extra path of lambda by 2 will be involved. So 2T will be equal to 2n minus 1 lambda by 2 for constructive interference, and for destructive interference it will be 2T is equal to n lambda, right? So this is the constructive interference and this is the destructive interference. These are the conditions corresponding to which we get the bright fringes, and these are the conditions corresponding to which we get the dark fringes. Now let us try to elaborate this diagram a little more. Suppose we complete this circle. So we have a plain glass plate on which we had actually mounted this, and we complete the circle, right? The thickness was T, the thickness of the air film that was trapped between the two, that is T, right? So we do it like this. It was a plano-convex lens, right? So let us name these points A, B, C, D, suppose B, right? So let us name this distance, which is actually the radius of the plano-convex lens, as small r, and let the radius of the entire circle be r. So up to here it is r. The radius of the plano-convex lens is small r, and the thickness of the film is T. Now from this figure we can evaluate certain things. That is, by using the theorems in circle that you have learned at a very elementary level in class 9th or 10th. On account of symmetry, we know that AP into PB, this is the same thing as CP into PD, right? So what is AP? It is R, small r. This is also small r, so this is R square. What is CP? It is the thickness of the film, maximum value of the thickness, that is T. And what is this PD? It is entire diameter of the circle, that is 2r minus the thickness T, right? So it is 2r minus T. So how much is that? R square is equal to 2tr minus T square. We know that this plano-convex lens has trapped a very small thin film with this plain glass, right? So the square of this t can be neglected. So in all we write that r square is equal to 2tr, or this 2t is equal to r square by r. Now you can choose to put this value of 2t equal to r square by r here and here. So what do you get? You get that you get r square by r is equal to 2n minus 1 lambda by 2, and here you get r square by r is equal to n lambda. Therefore, that means from here we can take it to, I'm putting a star here, so we can take it here. In all you get that this, for dark fringes it is under root of n lambda r, and for bright fringes this is r is equal to 2n minus 1 lambda by 2 capital R, right? In both the cases, whether it be the dark fringes or the bright fringes, we see that the radius of the fringe is proportional to the square root of the radius of curvature of the bigger circle, right? Now, in case of a dark fringe, when we put r equal to 0, and why do we do that? Because at the center, this plano-convex lens is actually touching this glass plate. So when r is 0, this r is also equal to 0. That means the central fringe is going to be a dark fringe, will be a dark fringe. And around this dark fringe, you are obtaining the alternate bright and dark fringes. Bright and dark fringes. Right? So this is the pattern of the interference that we obtain as a result of the light that is reflected from the system. Now remember that there is also a part that is transmitted. And if you see the pattern of fringes in that transmitted pattern, you will see that the scheme of derivation and is same, right? The only difference is that since reflection is not involved, this phase difference or this path difference of lambda by 2 will not be introduced. The conditions of constructive and destructive interference will be reversed. That means this will be the condition for constructive interference and this will be the condition for destructive interference. And by the same scheme of derivation, we get that the central fringe will be bright, followed by the alternate dark and bright fringes, right? So that's all about Newton's rings apparatus. It's a beautiful experiment and you are going to learn it in a more elaborate manner in the lab course, and that we will be doing subsequently. Now Newton's rings apparatus also has many applications to do with. One is to find the wavelength of the source that we used in the course of experiment. Another is to find the refractive index of certain material, as we did in case of Michelson's interferometer. That we shall be doing in the subsequent video. So that's all about Newton's rings apparatus.